All right, y'all, so this one's going to be a fun one today. We're going to use GPT to actually work with real-world data. And I have a fun little example for us to follow along, but GPT is incredibly skilled at just taking a stream of data without a whole lot of context, figuring out what it's about, and then actually doing useful things with it. So for today's lesson, we're going to use the log files from my weather balloon tracking computer. So this computer is actually up in my attic. It's kind of out of reach right now, and it's up there because the higher something is, the higher a radio antenna is, the further over the horizon it can receive signals. And so this computer and radio is supposed to track balloons down as far as it can go. I just try to get up as high as I can with the antenna and see as far as possible, essentially. And so each time the National Weather Service launches a weather balloon out of the Nashville location, which is twice a day, my device tracks it. It tracks the flight up and it tracks the flight down, and eventually it drops off of where it can see, right? It's called the radio horizon. Eventually the payload goes below the radio horizon. Well, eventually after the balloon goes below the radio horizon, it's going to hit the ground, right? But somewhere between my station losing contact with it and the ground down here, it does something. It has this track, right? And that's what we're going to use GPT to predict, is where it lands on the surface of the Earth after it loses the radio contact at a certain height. It's different everywhere, but it's based on the terrain around my house. But once it loses contact and the balloon falls down to the ground, then what we're going to do is take the data from up here that's still in the log file on my computer and put that data into GPT and say, hey, what probably happened here? What was it that occurred here, and where can we look to find the balloon in the real world? So I'm going to show you the process for doing it. I just wanted to give you the kind of the strategy of what I'm doing and why I'm doing it. And again, this is a hobby application, but you can do this in business, entrepreneurship, solving practical problems around your house. You can use this kind of approach to process data with GPT. So let's get started. Okay, so this here is something called VNC Viewer. And VNC is a way to remotely log into a computer. So that's how I'm able to access my little Raspberry Pi microcomputer up in the attic without actually accessing it physically. It's connected to the wireless network. VNC Viewer is very easy to set up, and a lot of Raspberry Pi operating systems have it natively installed. So we just right-click on this VNC logo, and then we go to File Transfer. And in File Transfer, what we're going to do is we're going to do Send Files, and that means send files to the desktop that I'm using to access it. And so we just navigate to where our log files are stored. So for me, that's going to be in the devices folder here, and then it's got a little log folder. We navigate there, and then we see these .log files, right? So what we're going to do is we're going to grab one of these .log files. Let's take, because you can see what date it is right here, 6/23/6/23. Let's just go ahead and take this one here, that's 6/23 one, and it will download to my machine. It is now on my computer. So I'm going to go to my downloads folder, and now I'm just going to go ahead and open this file. So this is what the weather balloon folder looks like here. This is all of the log data. It's got thousands of lines of data here. This is what the weather balloon's little radio sonde, it's called a radio sonde. It's a little unit at the bottom of the whole balloon thing. It's sending out this data line by line by line by line while it's flying. And here's the legend up at the top. It's the timestamp, the serial of the device, frame, latitude, longitude, altitude, velocity vertical, velocity horizontal, heading, temperature, humidity, pressure, type, frequency in megahertz, signal to noise ratio, and then we have some other things here as well. So what we're going to do is we're going to take a big chunk of this data, and we don't have to necessarily understand all of it. We just need to know like where it came from, right? And that it has location and movement data within it. So I'm just going to go ahead and close VNC here because we're done with that. We already got our log file. And now what I'm going to do is I'm going to go into GPT and I'm going to type in a prompt. And again, a prompt is when you tell GPT what it is that you want it to do. So I'm going to say, I have a data file that I want you to use to analyze. How about we say that I want you to analyze and use as input to, we'll say, extrapolate. So that's kind of like extrapolating is like taking some data and then using it to predict something else. It's like extrapolating outwards. That's what we wanted to do with this data. And so we use it as input to extrapolate the lat lon at, let's say, 180 meters, because the altitude data in this is in meters, and 180 meters is a pretty general zero altitude here in Nashville, so it's 180 meters above sea level. And the data transmitted by the weather balloons is in metric system, so that's around 600 feet or so, which is the general above sea level elevation in Nashville. So when the weather balloon device hits the ground, it's at about 180 meters above sea level, so that's what the GPS would say. So I'll say, I want you to use the trends of vertical and horizontal movement from the data to do this. And that's just saying, hey, I want you to use this specific data, because it's pretty good at just kind of understanding that's what it's supposed to use anyway, but I want it to actually look at a lot of the lines of data. I don't want it to just look at the last couple and do that. I want you to use the trends of it. And then I'm going to say, I'll say, please do not be verbose. Please do not explain. Please provide the output in the format lat lon. And then I'm going to say, are you ready for the data? So we'll send this to it. So it took it, and it's like, I can try. Well, I guess it's getting explaining here, but we'll see if it works, right? I've had this work for me a few times. If we have to, we'll use an older example. So I'm just going to grab the last few dozen lines of code here, or lines of data here, and I'll just paste it in and see what it does. Well, look at that. It did give us this actual output. So let's go and look at this on Google Maps. So we're just going to copy this. Then we're going to go to maps.google.com, which is where you can put in latitude, longitude. And now you have to remove the slash here and replace it with a comma and then put a space there. But if you hit enter, this will pull up a specific place, right? And so this is where it shows that this weather balloon should be. And actually, this is not the best result. It actually ended up being like right here. But considering, and this is just like a little spot I saved so I know roughly what neighborhood to look in when I go look for this one. I actually went and grabbed this one this morning, but it ended up being here. And I don't know if this was accurate or not. Here's the problem. Somebody had actually found it in the neighborhood and just like dropped it next to the road. So I don't know if GPT's prediction of it being right here is accurate or not. It could be that somebody was out walking in the field, grabbed it, and then moved it over here. But it had obviously been tampered with. It had not fallen there. It was missing a piece on it, and it had like marks like something had grabbed it. Something mechanical had grabbed it. So it's quite possible that this was picked up by somebody like riding a four-wheeler through here and like cleaning the place up, because this is a little airport here. This is a little runway. And it's quite possible that they just deposited it next to the road like, okay, the trash crew is going to come get it. So we don't know on that one. But I am going to show you one that this did work on that had not been tampered with, right? So I'm going to grab, let's see, I believe it was this one here. So this is one that disappeared in a thunderstorm at about 1,500 feet above the ground. And it was moving at 65 miles an hour. So there's a pretty big range of area that it could be in, right? And so I asked it to do it, and it was kind of verbose here, right? It's explaining what it did. And then I said, just give me your best guess here. And so what I'm going to do is I'm going to grab these latitude and longitudes here, paste them into Google. So we'll replace that one there, and then we'll grab this one here, and we'll replace the other one. And we'll see if this is actually the right one that I'm looking at or not. But I'm going to grab that, and oops, we're going to paste this, and then we're going to see if this is the one that I'm thinking of. It is. Looks like it is. So it predicted that it would land right here. And so let me actually show you on the weather balloon website where this ended up. So let me grab the balloon serial number here, and I can actually look this up on the weather balloon tracking website, sondhub.org. So what we're going to do is we're just going to paste this serial number here, and we'll see what the data looks like. So this is the data of how this balloon flew. This was during a thunderstorm, and as it descended back through the stratosphere here, it ended up right about here. So the algorithms on the website here were incorrect. It said that it would just like turn left here and just like go this way. That was incorrect. So this was traveling at it doesn't say anymore here because the site forgets these things, but it was traveling at 65 miles an hour. It was heading almost directly south parallel to this road, and it could be anywhere, right? So let's switch this to satellite, and let's look at let's look at where GPT predicted it would be. So this is where my station lost track of it, right? It lost track of it way up here. And we'll use this airport here as kind of a visual marker for what we're looking at. So here it is, way up here, more than like 2 runway lengths away, or about 2 runway lengths away. Here's the airport, and here's where it lost track going 65 miles an hour south. So let's go and look at where GPT said it would be. And right here is where my station lost track of it. Right here is where GPT said it would be. And so let's zoom in on this. And I actually went and got this one. So this piece of property here is for sale. This house is abandoned right here. There's nobody living there. The windows are boarded up, and there's a for sale sign out front. But I actually spotted it from the road when I was driving by here. And just to give you an idea of how close this was compared to where we lost it. We lost the balloon up here, right here, up at 80 Road. I was driving down south here, and I was looking off to the right, and over here I spotted it. It was not actually in this field. It was hanging on this fence line here, less than 650 feet away. So GPT actually did an excellent job, because this right here is where it landed. And let's just measure distance here. So we'll measure distance to here. So it's like around 650 feet from, it's right about here, around 650 feet from where GPT was like, hey, it might be right here. That's amazing. That's pretty excellent accuracy, considering there was atmospheric turbulence, there's gusts of wind, there's heading changes of the wind during a thunderstorm. There's a lot of chaos in where this could be, and this is probably about as good of a prediction as you could get. And so let's go back and look at the prompt. I said, please predict the lat lon at altitude 244 meters, because I went and looked at the elevation of that little airport there. It's really easy to do that. And it was 800 feet, converted that to meters. Please extrapolate. Great accuracy is not needed. Please do not be verbose. Here's the data from which to extrapolate lat lon. And so then it's like, well, I'm going to look at this data set. It looks like it's a moving object's geolocation and altitude. And the fact that it can figure that out without too much additional help is amazing. And then it says it looks like it's descending. And then it shows its work here. It shows its thoughts. And it shows like this data from like 8 o'clock to 8:36, or this like 36-second chunk of data here, which it uses, the thing transmits a new chunk of data every second. So it's like 36 lines of data here in this 36 seconds. And it figures out it's descending about 5.2 meters per second on average. And then it said it would take approximately 81.9 seconds at that descent rate to go from 670 meters to 244 meters. And then from there, it does a latitude longitude extrapolation. So I can do this part. I can do this part by hand. It's pretty easy. You just find the average descent rate, and then you see how far it has to go, and then you take how long it would take to fall, and then you look at how fast it was going horizontally and multiply that many seconds, which is 81.9 times the average ground speed. But the latitude longitude part, that's a difficult calculation, and GPT just does that out of the box. We don't have to train it to do this, which is crazy. And then it says, I don't know, I might not be able to do this. And I said, this is the best data and model that we have. Please work with this to provide the estimate. It is understood that it's prone to inaccuracies. So something about GPT when you're working with data is it really doesn't like being inaccurate. It doesn't like to tell you something that it's not very certain about. And so I had to convince it to do this. And so it said, okay, let's proceed with a simple linear extrapolation model. And then it just, like at the end, says, please note this is a rough estimation based on the given data. It might vary due to numerous factors not accounted for in this simple model. And these are the coordinates that it gave me. And again, this was about 650 feet from where I actually found it. So I knew where to look. I have a drone. I can use that to spot the big orange parachute on these things. And it's not super hard to find it from the air once you know approximately what area to look in. So it takes it from a needle in a haystack to finding a needle maybe in a little pile of grass. It's not that hard. But again, this is working with data. I just used the weather balloon data as an example. There are all kinds of ways to measure your environment, like temperature, noise levels, radio signatures in your environment. You can do that with a software-defined radio. You can build all kinds of tools and devices to actually measure your environment and get a big stack of data. So you don't have to chase weather balloons to get data to work with, obviously, in GPT. And this is something that I believe is a huge opportunity. So for the entrepreneurial among you, which that's a lot of homeschoolers, right? A lot of homeschoolers are like, hey, I want to start my own thing. Not everybody, but a lot of them. And this is actually what I'm doing. Like, I have this future homeschool project here, this futurehomeschool.com project here, where I teach homeschoolers how to use artificial intelligence. But my main business is actually helping businesses apply AI tools to solve problems. And the solution itself might not be artificial intelligence in the end, right? So when we did this, when we analyzed this data here, the end result was me driving down there and looking for it with my eyes. We didn't actually use AI out in the field. We used it to get us a prediction. So sometimes the solutions you can create are not going to be necessarily AI itself, but you'll use AI to arrive at that result. Another example of this is I needed to figure out how to this is a very good example of a real-world application of AI where the end result is not artificial intelligence itself, and nor do you even have to touch AI to use it. This is something that you can actually build a piece of code, and then that solves a problem for you. So I'm a decent coder. I know enough about Python to write a few lines, right? And I can look at some code and kind of understand it, but I'm not an expert. But GPT is probably a top 10% coder, and it's very good. So I described this problem that I was having with my Raspberry Pi up in the attic. So it's in the attic, and it's the summertime in Tennessee. It gets very hot in the summer. And this is an example of using artificial intelligence to solve a real world problem. And this is where I think there is entrepreneurial opportunity, is just doing this for people, like solving their problems. My computer would actually overheat in the attic, and so it would stop working, and like I would have to reset it every day, which that's kind of a pain to go up there and reset that computer every single day. So I figured that I could put it on a Christmas light timer, right? So I could have it run during the times of the day when there's a weather balloon in the air, the 3 hours or 3.5 hours, or just to be conservative, 4 hours twice a day, where I want it to be listening for these signals. The rest of the time it can shut down and cool off and not be getting into an overheated state. But the problem is when the little Christmas light timer thing gets to where it turns on the circuit and the computer boots up, this code does not automatically start. So I would still have the problem of having to go to VNC and log into the device and then start it up manually, type in the commands to start the listening program, and then it would start listening. So I would still have to do that twice a day. And I've got a lot going on. Sometimes it's easy to miss that, and then I miss an opportunity to track a weather balloon and get its data, which I can use in all kinds of projects. But I figured, what if the code could start at launch? So what if this program could begin running when the Raspberry Pi computer booted up? As soon as that switch turns on and the computer turns on, what if the code started then? So I said, I want my Raspberry Pi to run a .py program at boot. How can I do this? And then it said there's several common ways. And so I tried these ways and it wasn't working. And then I said, I got this error after checking the status after reboot, and then I sent it like the log file of it trying to run my program, which it told me how to find. Don't worry, it's not something complex that it's like, well, how do I find that? You just ask it how to find it. It says, thanks for the detailed error message. It seems like here's the line that's causing the problem. The fix to this is this, and here's where the code you actually need to type into the terminal window in your Raspberry Pi to make this happen. And so I went through and typed that all in, and then I said, well, actually the error message was this, I got it wrong. And it was like, oh, well, in that case, here's something you need to do. You need to go to the service file and put in this stuff here. You need to change these settings. And then it gave me the settings to it. And then I was like, well, what's the command to edit the service file? It's like, what's a service file, dude? And it's like, okay, here's how you do it. You just type this command in. And I was like, okay, I can do that. So I typed this in, and then it still wasn't running. And then I gave it the error. I pasted the error in there, and it was like, oh, well, it looks like the error message seems to indicate that the Python script is not able to find a configuration file. What it did is it figured out that I was running it in the wrong directory. So I had the thing set up right, but it was pointing at the wrong folder on the computer. This is a common kind of thing when you're working with code, is you'll figure out that, oh, everything's working properly, but this one really simple thing, like picking the right folder for the code to run in, for it to find the program, is what's broken about all this complexity. It's like the simplest thing often that's broken with code error. And that says you need to reload it and restart it. And then I said, how can I confirm that it's working? And then eventually I got this up and running. And I had to go back and forth with this. It probably took about an hour to an hour and a half, just because I'm kind of a noob when it comes to running this stuff. But I got it to work. And I had to ask it a lot of questions and send it a lot of errors. But now, when my computer powers on, as the Christmas light timer switches it on and it boots up, it now runs this code. And I'll show you what it looks like on here. I actually can log into this program directly from my machine without using VNC. Oh, well, looks like it shut off. Never mind. The Christmas light timer has turned it off. I've recorded this a little bit too late, so it shuts off around 10:45. But this runs every time a weather balloon's in the air, and it logs it, and I'm able to track it and go find it if I have time during the day, and it's really fun. But this solved a real-world problem for me where my computer was overheating, and I figured, well, if I can just turn it off when it's not being used, then that would solve the overheating problem. And then I realized, well, I need it to start running when it boots up, and this actually helped me figure out how to do that. And so I solved a real world problem for myself. And again, this is a hobby. It's not like life and death stuff here. It's not like going to make me a bunch of money. All it's doing is saving me a little bit of time and making it easier to pursue a hobby of mine. But the same exact kind of process can be used to solve $1,000 problems, $1 million problems, or even just make someone's life a whole lot better, or even your life more convenient. So just know that you can use artificial intelligence to do all kinds of cool stuff in the real world, and that might just mean that you're figuring out how to run a Raspberry Pi here. And this is a $15 microcomputer, right? It's not like a super expensive thing. It's not super hard to use. Raspberry Pis are kind of hard to find right now. Let me pull up our Pi tracker and see if there's any available. But this one is the 02W that this is running on. And oh, looks like there's actually some stock, which is great. And then there's a 0W. This is the 02W, which is a little bit faster computer than that one. But this is rpilocator.com. This is what I use to find where it's in stock, because it can be kind of hard to find. But this is a really fun tool to use, and GPT makes doing stuff with a Raspberry Pi much easier than it was back when I started playing with Raspberry Pis earlier, where you had to actually learn like these commands to type into the like the terminal window just to get it to do some basic things. Now I can just have GPT walk me through what I want to do, right? So hope this lesson was inspiring and educational for you. Check out the homework and the additional study, and I will see you in the next lesson. Love y'all.